Hope it will work. Scribbling, you are able to see, no? All
Yes, sir. Clear, sir. We can see it.
you can see. Let's see. Okay, no, we'll continue here. Okay, this adiabatic process. So it's a process in which no heat exchange. No heat exchange will occur. So no question of it. So it's not like 10 joules it will absorb, then 10 joules it will nothing. No heat exchange altogether. So here Q will be 0. So therefore what we can write here now? We know Q equal to delta U plus W. Q is 0. So delta U equal to W. Or what is this? Strictly work done by the gas. So therefore this work done by the gas should be equal to minus of delta U. So there's one basic necessity condition for the adiabatic process here. In adiabatic process, the work done by the gas will be negative. Okay, let's go for this one. So how pressure and volume, PV, eraser not working. PV to power of gamma equal to 1. How pressure and volume are related like this. So what is gamma? Gamma will be Cp by Cv. I think if you can remember, adiabatic exponent of gas. So what is this is? This is called as adiabatic exponent of gas. So it is called as Cp by Cv. So for so adiabatic process, pressure and volume, they are related by this equation. Okay, let's replace pressure here. So can I write nRT by V? Gamma is equal to constant. So this will become TV gamma minus 1 is equal to constant. So how the temperature and volume, they are related by this equation. Okay, let's go for the how pressure and temperature are related. So this volume, I can replace volume if you want, I can replace in terms of pressure, that one. So this will be V, what we can write it as nRT by P. So P1 minus gamma T to power of gamma nR gamma equal to constant. It's a gamma, not R, it's a gamma. Okay, there's one more formula. The pressure and temperature are related by this one, P1 minus gamma by T to power of 1 by gamma. Okay, this is about the relationship between the pressure, temperature, volume, pressure, volume. Very important, I think at many places, this equation will help us in deciding the, so what you can say in deciding particular graph or your things. At many places it will come, not only here, at many places it will come. Okay, let me. Yeah. Okay, let's go for the work done. Any formula? I think I'll use this particular delta U formula. Work done by the gas is equal to work done by the gas equal to minus delta U. So therefore, what shall I write? This delta U, nr gamma minus 1 delta T, nr gamma minus 1 Tf minus Ti. So this can also be written as, so PV could nRT from that, or nr gamma minus 1 Ti minus Tf. So nRTi, nRTf. This is gamma minus 1. So what is nRTi? We can write it as Pi Vi gamma, or Pi Vi will write it. Anybody what to replace here? I'm just giving some. So shall I write Pi Vi gamma? You know in chemistry also, no? So therefore I'm just trying to test your memory. Shall we write like this, or Pi Vi shall I write? Please do recollect. Shall I write Pi Vi to the power of gamma, or this one? Only it's a, what it is? It's a ideal gas equation, no? So this will not come. Fine. nRT PV equal to nRT. So there's a work done by the gas in adiabatic process. Okay, this will be a very easy formula to remember for you. Huh? Okay, this will be PF. Fine. Okay, this is about the work done. What about work done by external agent? Because say, what is work done by the gas? Means here, as the gas does positive work, intensity decreases. So what is the convention here? If the work done by gas, positive, internal energy it decreases. If the work done by gas, negative, internal energy will increase. Okay, there's a basic conditions. When a gas does positive work, this one. So what do you mean by this, sir? We are not understanding anything. Okay, you are writing mathematics. Okay, just I'll give a simple example. Let's go for our same, the piston idea. Okay, here the gas is present. So it will exert a force P into A. So it was having temperature, say like a T1. Okay, P1 into A, it's having a volume V1. So this gas will exert a force, no? And because of that, what will happen to piston? The piston will move. So after some time, so where the piston has come here. Tell me like who has pushed the piston? The external agent only. So here this piston will have mass. So it is having a velocity V. Then it was pushing with a force. Now P2A, temperature T2, this is V2. Now tell me like from where this kinetic energy for piston has come? Because the gas is doing work. the gas is in fact doing work. It is applying a force. When a body is acted upon by force, tell me what will happen. When a body is acted upon by a force, it will accelerate. Due to acceleration, speed will increase, kinetic energy will increase. So therefore, what will happen to the kinetic energy of piston will increase. From where this kinetic energy is coming, the gas is doing work. From where, what energy of the gas should decrease? The intensity of the gas will decrease here. This is a very simplest idea, nothing to do big. So therefore, when the gas does positive work, definitely the intensity will decrease. You can see here, when gas does positive work, intensity decreases. So how do you can see? It's very simple. The force will act on a body, accelerates, speed will increase, kinetic energy increases. Tell me like which energy should decrease? The intensity of gas will decrease. So the gas is having ability to do work. This is something very, very important here. It can move the piston. This piston I'll connect to wheel. The wheel will start rotating. This was the diesel or petrol engine. Finish or nothing big. Getting some? No. If external agent slowly moves the piston, if external agent moves the piston towards left. So here you can say what will happen, temperature of gas will decrease, no? Then intensity of gas decrease. The decrease in intensity get converted into increase in kinetic energy of gas. Sir, what is work done by gas? Work done by gas is what? Increase in kinetic energy of the piston. This is the meaning. So if I move the piston slowly towards left, external agent, then external agent is doing work. Where the energy of external agent will go? Converted into increase in intensity of the gas. We can also put it in another way. So if it is a the piston is here. Now external agent will push that piston. Fine. So this is the gas. So this is the external agent. Slowly let him push. Then the pressure here, it was P2, V2, temperature. So this is P1, V1, T1. So if you come and check T1 greater than T2. Here also the same condition. No. Temperature of gas will increased. Intensity of gas increased. From where this energy has come, the external agent did work. So therefore, work done by external agent should be mod of or say plus delta U. Work done by gas should be minus delta U. I think this is something very important here. So you do get a problem where external agent will be pushing it. So as external agent does positive work, the intensity of gas increases. External agent does negative work, intensity decreases. So here what is work done by gas will be negative, because as I move piston towards left, the force by the gas, the pressure force of the gas will be towards right, no? So work done by the gas, if it is negative, intensity increases. That's what it's telling. Okay, we do get problems where I'll be using this one. Okay, this is about the basic, the adiabatic process. Let's go for graphs. Let's see that how different types of graphs are in adiabatic process. So first, the PV graph. Pressure versus volume graph. So it should be
Sir, good morning, sir. This is Gopi, sir.
Good morning, sir. Chepandi. Yeah.
సార్ ఎవరో స్టూడెంట్ నేమ్ 555 అని ఉంది సార్. ఈ సెక్షన్ అయితే నేమ్ చేంజ్ చేసుకోమని ఒకసారి చెప్దాం అన్నట్టుగా ఫోన్ చేశాను
సార్. నేను యా రిమూవ్ చేయాలా?
స్టూడెంట్ ఎవరమ్మా 555 పర్లేదు సార్ 555 ఉన్నారు. ఈ సెక్షన్ అయితేనే ఉండండి, లేదంటే ఎగ్జిట్ అవ్వండి అమ్మా సార్. ఓకే, థ్యాంక్ యూ సార్.
యా ఓకే సార్. Can you hear me?
Yes, sir.
Yes, sir.
What's happening today? Zoom is not responding. You can hear me, no? Yeah.
Yes, sir.
Yes, sir.
Screen also you're able to see. Huh?
Yes, sir.
There's a problem with the Zoom software today. Okay, no. We have, so it will be like this. Huh? Pressure, volume. Okay, this will be. So I want the not working. Cursor moving. I think not moving. No. Arrow.
No, sir.
Not moving. No.
No, sir.
What to do now? Okay, this is up arrow, down arrow. Okay, no. Yeah. Let me screen share again. Huh? This is zoomed. We have a problem. I'm not getting any controls here. Okay.
So now you became the host, sir.
Huh? Now can you see the screen?
Yes, sir.
Yes, sir.
Okay. I don't know. Sometimes it will trouble me a lot. Huh? Yeah, I think we can proceed. Eraser button is not working. I have to check again for any virus there. Yeah, there's the pressure. There's the volume. Okay, now what about the work done? I think it's again, we can't find out the area, no? This will be. So there's the pressure P2. So P1, V1, V2. So there's a pressure P2. This will be pressure P1. So if you check again, so can you find out, can we take help of the area under the curve to find out the work done? So not possible. Any reason for that? Because it's not a curve, that one. So therefore, how to calculate the work done? So again, what we do is, I'll already we have brought formula. No need to integrate again. First, I'll calculate the small elemental strip. I'll calculate the work done. I'll get that one. So there's a how pressure versus volume graph will be. Don't say rectangular hyperbola. It's a curved one. The equation what happened should so PV to the power of gamma equal to constant. Okay, this is the basic condition. So the pressure and volume. Okay, let's go for similarly how the temperature and volume are related. Temperature and there's a volume. So the curve will be, so what is the formula for this? This will be TV gamma minus 1 equal to constant. Can you remember this? So similarly, we'll go for the pressure versus temperature graph. There's a pressure, there's a temperature. So the curve will be, any formula for this? P1 minus gamma T gamma. I think they are going to help you a lot when you're plotting equivalent graphs. So how do we can check it here? So here simplest thing, dp by dv, what it is equal to minus gamma p by v, slope, this one. Similarly, dt by dv, you have to differentiate it. Let me write directly. Differentiating this. Anybody differentiate this equation? Dt by dv, this should be equal to minus of gamma minus 1 t by v. Again, t, what you can write, v gamma minus 1. T equal to 1 by v gamma minus 1. So therefore this will be, so some constant it should come. Some constant, I'll introduce alpha, where alpha is a constant. Okay, similarly P gamma, so you can write one equation for dP by dt also. Okay, like this, the slopes will help us to plot the graph. So how pressure and this volume and temperature are related. So the formula will be, I think this will be pressure versus temperature. No? So this equation, you just remember it. This equation will be sufficient. So if you take monatomic gas, substitute the value, pressure versus temperature, you'll get a curve. And that curve will corresponding to this particular thing. Monatomic gas, gamma will be 5 by 3. Substitute that and check it, no? So you get a curve which will be of some sort of like a parabolic. I should not say parabolic, but similarly of that particular kind. So for monatomic gas, just we'll see for gamma equal to 5 by 3. It'll be easy for us. P1 minus 5 by 3, T 5 by 3 equal to constant. So let me solve this. So this will be minus 2 by 3. How to plot graph? You can assume monatomic gas, you'll get gamma value. So this will become T to power of 5 will be proportional to some constant P square. I think you plot this graph, it will be of this kind. Okay, I agree this one. Okay, let's take the
A constant into p squared, no sir. T power 5 should be.
T to power of 5 equal to constant into p square will come there.
Yes, sir.
P square. Okay, this one. And I'll rewrite here. Okay, now regarding the isothermal adiabatic curves, we'll compare it. If I plot the isothermal graph, so let's draw the graphs here now. This is the so which one will represent isothermal? Which one will represent an adiabatic? Okay, that is what we are trying to verify here. So this will be the pressure and there's a volume. Okay, there's a curve 1, there's a curve 2. Okay, let's get into the, for isothermal process, we write PV equal to constant. Let me differentiate P dV plus V dP equal to constant. So then based on this, dP by dV equal to minus P by V. So this is for, shall we say, isothermal, what we are discussing. Therefore, for isothermal process, dP by dV, the graph is given by this one. So similarly for adiabatic process, we'll see. I'll differentiate this P gamma V gamma minus 1 dV gamma dP. If I solve this, dP by dV equal to minus gamma P by V, I'll get it. So this dP by dV, this, let me call this a slope in for adiabatic curve. Now what is gamma? Gamma will be greater than 1, no? Monatomic 5 by 3, diatomic, all that one. So therefore, if I want to compare which will be adiabatic, which will be isothermal, gamma times more, the slope is more negative. So therefore, this will become adiabatic. This will be isothermal. So how do you can say the slope of adiabatic curve further? Okay, from let me divide these two equations. If I divide these two, so what do we get? I get gamma. So which slope will be more? Magnitude of slope. I think in math, don't think in terms of mathematics. I'm asking you to compare in terms of the magnitude here. So shall I say that slope of adiabatic curve will be more than that of isothermal. So adiabatic curves will be more steeper than isothermal curves. Are more steeper than okay, this is about the comparing isothermal adiabatic. Now, same adiabatic process, let me compare for different types of gases here. Monatomic, diatomic gases. Then what conclusion we can make it? Let me here. Okay, three different graphs. So first, Can we say anything about there's a pressure, there's a volume. Which one will be monatomic, diatomic, or polyatomic, or triatomic gases? So look at what is the expression for this? dP by dV is equal to minus gamma by PV. Gamma for which gas will be more? Monatomic gas. For monatomic gas, what is the first monatomic gas? Anybody gamma value? 5/3. For diatomic gas, 7/5. For triatomic gas, CV for CV for triatomic gas, how much it will be? Non-linear triatomic gas. It will be 6, no? CP will be 7. Shall I write okay? This much? All of you okay? This one, gamma, CP by CV. No response from anybody?
4/3, sir.
Sorry, this will be 4/3, no? Okay, no. Tell me which gamma will be more. Gamma for monatomic gas will be more than diatomic. Please mute it. Please mute it. Please mute it. Mr. Yochan, shall I remove or will you mute it? Please don't trouble me, no. Already we are facing a lot of problem. Huh? Okay, so
Sorry, sir.
Again, don't say sorry. Huh? Leave it. Don't disturb class. Huh? Monatomic, diatomic, there's a triatomic. Okay, clear this one. So the curve